Buddy, welcome to Rabbit Hole. Good evening. Yeah, good evening over there on Twitch, YouTube, and Rumble. Good evening. Welcome to Saturday Night Rabbit Hole. Yeah, this is fun. I love this subject we're going to be talking tonight about. Um, this is part two. We just kind of gave you a little test or a little taste of it last week, but we're really going to start a new series on how the North American plate moves. And kind of like sheets of ice, they break apart and then they get bounced around. And as they get bounced around, one plate moves another plate, which moves another plate, which moves another plate. So we're all good. And remember, this is going to be a pretty detailed uh, series and a lot of data. And our supposition is that we've are leaning toward being able to trace how North American plate moves and how pressure, which becomes visible through earthquakes and fires and other stuff, is seen in how we can watch the North American plate move across our planet. And it bumps into other plates, and then there you see earthquakes over there. Where it starts, I don't know. Maybe it starts in the Galapagos, maybe Rapa Nui. We don't know. But what we're saying is we can see the pressure move across the United States, especially over the last 2 weeks. Very interesting earthquakes been going on. And I want you to sit back and listen. And we're going to throw a bunch of data at you, and we're going to try and summarize, but we'll do our best. And I know my brother Canucks chomping at the bit. And so I have Canuck on me with me here, not in studio, but via virtual. And my other brother Luke, he's out there driving. He's probably not quite out of Colorado yet, but he's moving over there. And moving means he's going back home. He's been driving. He's over 900 miles already. So hang in there, Luke. We love you. And hope you have a good time tonight listening to this rabbit hole, which is dedicated to you, brother. Be safe, and look forward to seeing you next year. This time, well, anyway, we'll go with that later. Anyway, Canuck, welcome. And thank you for all that you've done by presenting these series of articles and research that you've been doing to bring about a clear look into the murkiness of how earthquakes work and how they reveal the mechanism that is moving our planet. And again, just earthquakes aren't the end all or be all. They're just a evidence that the plate's moving. And we'll talk about lineaments again tonight, electromagnetic lineaments, which now the USGS is talking about, and other groups who study earthquakes are talking about more and more and more and more. And how the sun kind of, plays a role with that. Also, other bodies out there in the universe or in our solar system or in the universe. All of it's part of a large system that has interplay. We, being life on this planet, have a real tenuous grip on our existence. Certain things have destroyed life on this planet several times over, and not saying that's going to happen anytime soon, but the historical record shows, dinosaurs died. Remember that? Yeah. But before dinosaurs dying, 90% of things were wiped out by the Mid-Atlantic Ridge. And we're going to talk a lot about the Mid-Atlantic Ridge. And specifically, you want to start in the Azores, or where would you like to start tonight?
Well, I'm just going to give like a little review. So
go ahead.
Yeah, in the last show, we focused in on the new Madrid quakes of 1811 and 12 and showed what happened before, going back probably 2 years before to see what led up to them. So what we basically did is connected a big quake in Crete in 1810 all the way across through Azores, and then all the way across through New Madrid, and then all the way to the two big quakes at the end of 1812 in Southern California.
Mm-hmm.
So all in like 2 years' time on like an east to west line. And so what we're going to do tonight, I'm going to add in some more other things that I didn't have time for that was going on that same east to west line. And then we're going to start going back in time using New Madrid to find out when it had big quakes before that we know about, and see how that connects across to California. And we're also going to see how it connects to Cascadia too. So it's going to be fun tonight.
Right.
We're going to go back 1,000 years in time to see how this all connects.
All right. So right now we're on Twitch, and let's rock and roll. Streaming here too? Yes, sir. Just music. Oh, shoot. Turn the music off. Yeah, we've been talking this whole time, and sorry. Hold on here. Good evening, everybody over there on Twitch. We are live. We're going to talk a little bit about North American plate movement and the evidence visualized in Timmy, you're a little bit late, buddy. I already killed it. Visualized in earthquakes and other events that crisscross the continent of North America and South America and part of everything here. But anyway, across North America. So you guys are up to date. More volume. All right, let's see here. Let's see if I can. I don't know how to turn more volume up. More volume on my mic or more volume. Then there's a delay. Oh yeah, there's a delay. Let's get rid of the earth. You see my mug. There we go. All right. Kill it. Oh, it runs out slowly. All right. Good evening, everybody. Good evening. I'm your host, Joe Slick, and with me tonight is Professor Canuck. I call him Professor because he's professing to know or to be a triple decker brain. He doesn't profess to do anything, but he's fun, and he's a hell of a researcher, and we're gonna have some fun. So now that recording's on and we're ready to go, how's the volume now? We 5x5, everybody. More volume. He already said more volume. All right. Oh, turn that volume up. Say hello there, Canuck.
Hello, everybody. Can you hear me?
Yeah, I saw the levels there. So my levels, turn up their max. There we go. Let me see here. All right. I guess that's as loud as I can get it to go. 5x5. All righty then. And bring this down just a hair. All right. So where would you like to start, Canuck?
Well, they couldn't hear my review before.
So go ahead and do your review again.
Yeah. So the last episode we talked about, we focused in on the New Madrid quakes in 1811 and 12, and we showed the lead up by going back a couple of years before those quakes to see what was happening. So we started with the 1810 Crete big quake, which was a 7.5, and showed how that came across through the Azores.
Propagated.
Yeah. And carried on right on through New Madrid in 1811 and 12, and then went across and made the two big quakes in SoCal at the end of 1812. And we basically showed a bunch of different ways that stuff was coming to make that. Primarily east to west, but we threw other stuff in there too. So what we're going to do tonight, I'm going to add a few more things in that I didn't have time for to do in that, and then we're going to go in our time machine back to 1450 by focusing on when New Madrid has gone off before, and I'm going to show how it's connected to Garlock in Southern California and also Cascadia going back in time. We'll start at 1450 and then work our way back. So it's going to be good stuff.
Always.
Yeah. So the first thing we're going to do tonight, I'm going to add a few other things from that was happening in between like 1810 and 1812 to show you what else was going on before New Madrid happened. So the first thing I'm going to go over is the Great Comet of 1811 that was flying over when all the New Madrid quakes started. So Joe has the link in there.
Yep, I had a link. Twitch can see it, and
so this is the space weather hook that we're going to go into more detail later. But so there was all sorts of crazy stuff happening back then.
All right.
Yeah. So I'm just gonna read the first part of this. Yeah. So the Great Comet of 1811. The Great Comet of 1811, formerly designated C1811F1, is a comet that was visible to the naked eye for around 260 days in 1811, the longest recorded period of visibility until the appearance of Comet Hale-Bopp in 1997. So everybody remembers that one.
Hale-Bopp, yep.
Yeah. In October 1811, at its brightest, and when it was 1.2 AU from Earth, it displayed an apparent magnitude of 0. So I guess that must be the brightness or however it is.
Mm-hmm.
With an easily visible coma.
You can you can see it, yeah.
Yeah. The comet was discovered on March 25th, 1811 by Honoré Flauger, guess. That's quite the name. At 2.7 AU from the Sun in the now defunct constellation of Argo Navis. After being obscured for several days by moonlight, it was also found by Jean-Louis Pons on April 11th, while Franz Xavier Baron von Zach was able to confirm Flauger's discovery the same night. The first provincial orbit was computed in June by Johann Karl Burckhardt. Based on these calculations, Heinrich Wilhelm
Matthias
Olbers made a prediction that the comet would go on to become extremely bright later that year.
This is back in March, yeah.
Yeah. From May to August, the comet's position made it difficult to spot because of its low altitude and the evening twilight. Both Flauger and Olbers were able to recover it in Leo Minor during August. Olbers noted a small but distinct tail consisting of two rays forming a parabola.
Mm-hmm.
Yeah. When viewing through a comet seeker. In August, the comet was first sighted in the United Kingdom by James Veitch of Inchbonny. By September, in Ursa Major, it was becoming a conspicuous object in the evening sky as it approached perihelion. William Herschel noted that a tail 25 degrees long had developed by October 6th. By January 1812, so we're getting into
the next year
playtime, yeah. The comet's brightness had faded. Several astronomers continued to obtain telescopic observations for some months, the last being Vincent Wisniewski in Russia, I think, Cherkask, who noted it as barely reaching an apparent magnitude of 11 by August 12th. The Great Comet of 1811 was thought to have had an exceptionally large coma, perhaps reaching over 1 million miles across, 50% larger than the sun. The comet's nucleus was later estimated to be 30 to 40 kilometers in diameter. In many ways, the comet was quite similar to Comet Hale-Bopp. It became spectacular without passing particularly close to either the Earth or the Sun, but had an extremely large and active nucleus. Now, I'm not going to read all the rest of this. I'm going to talk about the part where they talk about the New Madrid quakes. The comet was apparently visible during the New Madrid earthquakes in December 1811. A report on the first steamship to descend the Ohio River as it approached the confluence with the Mississippi River states, December 18th, 1811. The anniversary of this day, the people of Cairo, Illinois, and its vicinity should never forget. It was the coming of the first steamboat to where Cairo now is. The New Orleans Captain Roosevelt commanding. It was the severest day of the great throes of the New Madrid earthquake. At the same time, a fiery comet was rushing athwart the horizon. So that was pretty wild. So, like, when it was at its brightest or whatever, and it was most notable, was like right before this happened. So it's pretty interesting.
The closest it came was 1.2 AU. What does that mean? That's 1 1/4 full distances from the Earth to the Sun. So about the distance of the Sun and the Earth, plus 1/4 of that distance. That's how far away this comet was. That was so bright, they were able to see it. So that's pretty amazing.
So it's pretty wild. That was happening right at the same time. The New Madrid quakes were happening.
Right.
Yeah. So now we're going to go into other information of stuff that was happening around the same time. So that the next link we're going to look up is a Google search I did, and it gave me a bunch of Google AI information.
Right. Just so everybody's clear too, that comet's return happens 2742 years after 1811. So something way out there around so using an epoch of 2200 years shows the orbital period about 2974 years, which would give a return date of about 4785.
Yeah.
A long time from now.
For a while. Yeah.
Yeah.
Have to worry about it.
The epic of 1600 and the epic of 2200. All right. Yeah. And the distance is 391 AUs before. Now it's 413. So pretty crazy about this event happening at the same time. Is it just related, or is it just kind of fun fact? I think this is a little bit of fun fact, but
yeah,
we'll see. We'll see. So what's the next one you want to go?
Yeah, now we're going to go to the stuff that was happening that would be more related, like earthquakes and volcanic eruptions and all that. So I went back to 1810 again, because that was the lead up, and we had the big 7.5 Crete earthquake.
Not the Azores, so I don't know which link you want.
Yeah, it's the Azores one. So
okay,
in 1810, I wanted to see what else was happening in the Azores. So I refined my search, and I did the search 1810 Azores quakes to see what Google would tell me. And of course, now it always gives you the Google AI overview thing, which is I kind of like, because it gives me all sorts of stuff, and then I can go farther from there.
You can break down it. I'll read this one. In 1810, the Azores experienced a seismic swarm associated with volcanic activity on the islands, including eruption of Fogo Volcano and Pico Queimado. This event, also with other historical seismic activity, is part of the Azores history. of seismic activity and volcanic eruptions. Additionally, there is a mention of a submarine eruptions of 1811, further contributing to the volcanic and seismic history of the region. The Azores are located in a seismically active zone, and seismic activity, including smaller earthquakes, is a common occurrence. The region is also vulnerable to tsunamis associated with landslides or seismic or volcanic triggers. Azores Gibraltar Transform Fault, a major seismic zone, is located between the Azores and the Strait of Gibraltar. In 1816, a large earthquake occurred in the North Atlantic with an estimated magnitude of 8.3 to 8.9. It was felt in Lisbon and had a maximum intensity of a 7 in Madeira. On the Azores Island, violent shaking continued for 3.5 minutes, causing significant damage to homes and other structures.
Yeah. So basically, in the lead up to the new Madrid quakes, Azores was going crazy. And it kept going crazy even after 1812, all the way through until there was a big quake in 1816 that was in between Azores and Lisbon. So that's the summary for that. So once I saw this, I said, well, I'm going to go back and check out what other volcanoes were doing on the same east-west line from like 1809 through 1812. So that's what I did next. Because everybody knows that Etna's acting up right now. So I said, well, I'm going to search Etna. So the first thing I put in, I wanted to see what it was doing in 1809. So I put in 1809 Etna eruptions.
All right.
Google search.
So the AI overview. Okay, hold on. A minor earthquake coming through. Okay, in 1809, the eruption of Mount Etna was a major flank eruption that was characterized by intense strombolian activity, abundant ash emissions, and lava flows. It caused significant damage to the cultivated areas around the volcano's southeastern flank. So it was going off in 1809.
Yeah, so 2 years before all this other crazy stuff.
Mm-hmm.
Yeah. And I have some more information on here. I'm just going to read.
Oh, go ahead.
And it's only like one paragraph. The 1809 eruption of Mount Etna was a significant event, classified as a major flank eruption. It was characterized by earthquake swarms, long and fast eruptive fissures, and substantial lava flows, particularly impacting the northern side of the volcano. The eruption also injected a large amount of sulfur into the stratosphere, making it the second largest volcanic stratospheric sulfur injection of the 19th century, according to a study published in Copernicus.
Well, that means it means it's on par with the 1865 or 18. I think mid 1800s when the Indonesian volcano exploded. They're saying it's the second most strongest event that characterized by tephra being launched into the stratosphere.
Well, by volcanic stratospheric sulfur injection.
Yeah. So
a large amount.
You're talking. It's on par with Krakatoa, is what they're saying. That's a 19th century eruption. Krakatoa.
Well, you had other ones too, because you had Tambora, I think, was 1816.
Yeah.
And you had 1883 was Krakatoa.
Yep.
So they're saying this one was pretty crazy.
Crazy.
So, it's wild stuff. Like it talks more in this thing that I have about how it affected the climate and all this other stuff. Sure. I don't want to get into that right now. Yeah. My sister, I don't know what she's watching down there. She's freaking out about something.
Yeah, she is.
Yeah. She's probably watching telegram or something again.
But I got a map here, so let me show you. Okay. It's already
So
been
that's
shown.
1809, but I want to show that Etna kept going after that. So it didn't slow down. So the next one, I wanted to see when it went crazy again.
Mm-hmm.
So the next search I found, I did Etna 1811 eruptions.
Mm.
Yeah. So now I'm just going to read this one. And it's mainly a paragraph, so it's not going to take very long.
All right.
Yeah. The 1811 eruption of Mount Etna was a significant event. So here we got another significant event 2 years after we had the 1809 one, producing lava flows and ash that caused damage to cultivated areas and towns. It was characterized by intense, long-lasting explosive activity and was highly documented by observations at the time, including measurements of tephra deposition. So it dumped a lot of ash. Yeah, the eruption contributed to the formation of new features like Monte Simone in the Bow Valley. The Bow Valley is like, if you go way back in time, it had a blowout, like Mount St. Helens. So it has like a number of different summit vents that it shoots stuff out of, but it also has flank eruptions too, fissure eruptions. So to explain it, but this main one that happened in 1811 was on the southeastern flank of the volcano. So that's what it says. And it gives the dates and this other thing I looked up. So it started on October 27th, 1811, and it kept going to May 1812, which I thought was pretty interesting because the new Madrid quakes are right in the middle of that.
Right.
Yeah. So Etna was going.
It's Etna's bookending the New Madrid quakes.
Yeah. So it started before them
and
it finished after them.
Right.
And it kept going the whole time in between. So I said, well, that's pretty interesting. So I said, well, I'm going to keep going. I'm going to keep going and find out what the other volcanoes were doing. So I just kept going across to the usual subjects. So I moved over to everybody's favorite.
Capiflagree? Yeah,
no,
Capiflagree.
I'm doing Vesuvius first.
Yeah.
Yeah. And the Vesuvius link that I put in there is right long. It shows all the known eruptions going back to, or that they think they know about going back negative 5,960 BC. So it's a crazy list, but I was only interested in like what was happening in the 1800s. So I had to scroll down.
Vesuvius was erupting the same time that Etna was erupting in 1766, I see.
Yeah.
That's
and remember 17. I don't want to get into it. 1766 is when we had the big quake by Istanbul the last time.
So you have Istanbul, then you have Etna, you've got Vesuvius.
Yeah.
And is there some sort of event that hits the Azores? Can we?
Yeah,
we have a date
already. But
it's 1760. Hold on, 1766.
Well, I don't.
I'd have the Azores.
Look. I'd have to look. I don't know right off.
Yeah,
probably.
I wonder because right now we're seeing a couple of events happening on the date just 1766. Okay, it's also happened in 1811, everybody. But right now we're using, looking at 3 different areas and we're seeing all 3 connected.
Yeah.
And 1811, as I scroll down.
So I'm only going to go over 3 that it talks about in here.
Yep. 1810, 12, and 14. Wow.
Yeah. So it was going off. It had an eruption from its southeast flank, Vesuvius, in 4th and 5th September 1809.
Mm-hmm.
So it was going off in 1809. Then it went off again in 1810 from September 11th to 22nd.
Then 1812, February 28th, and from January 1st to February 28th.
So Vesuvius was going off
Well,
basically
interesting.
a whole bunch of times right before and right during when the New Madrid quakes happened.
Was Etna going off in that? It was, wasn't it?
Yeah.
Okay, so there are two. Well, now we're talking specifically right in Italy, okay? Sicily and Italy. 1811 or 1810 all the way to 1812. These volcanoes are popping. Boom, 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 boom.
Yeah. So we had Azores acting up. We had Etna acting
up. And Azores is a volcanic area as well. A series of volcanic islands out in the middle of the mid-Atlantic on what they call a triple junction, where the North American plate bangs up against the African plate in the Eurasian plate, and that's where the crux is. So it's happening there. Now going eastward, we're seeing that Etna is acting up. We're seeing Vesuvius acting up. I wonder what else we heard about a large earthquake in Turkey along these several different times.
Yeah.
Now now we know what's happened in North America because North America got rock and rolled these same years, right? We've got New Madrid, we've got Southern California, we've got I think we've got even Cascadia. Am I right in thinking there? 1811, 1812?
Well, we don't know for sure. And I can explain that because in around that time, early 1800s, that was when the Lewis Park expedition was going on. So they were the only Europeans up there at that time. So they were going around, and close to the 1809, 1810, they were near Great Falls, Montana, and they did feel quakes there, but they didn't know what it was from. So they didn't know if it was like, if they were feeling it from the coast or if they were feeling it inland. So they didn't know then. So we don't know what was happening in Alaska between 1788 and 1899, basically, because the Russians left Kodiak Island in 1788 because there was 2 large quakes at Sand Point, just like what we had in 2020 and 2021, and where their settlement was on the south side of the island. It's called Old Harbor now. That's where the Russian colony was. Well, it got wiped out because it got two tsunamis back to back. So they left Kodiak Island in 1788. So we have like a gap of 100 years of the Russians writing down quakes. Like the indigenous peoples were there, but they didn't have a dating system. So they would just say, like, if you came there and asked them or felt a quake, they'd say, oh, yeah, it does that. Well, fair amount. And then they'd tell you their stories about it and stuff, but they didn't have exact dates. We have to figure that out from all our technology we use now. So we don't really know what it was doing there between, like, Cascadia, like 1700 up until about 1899. So I assume like stuff was happening in BC and Alaska too, but we don't know for sure right now because nobody was there writing the stuff down. They've been doing all sorts of studies on tsunamis and faults and everything that they're getting numbers for, but they're in the process of putting all that together, which I'll explain more later when we get into 1450.
Yeah, the Alaskan ones are only listed 1788, having Alaska 8s, and 1755 Massachusetts had a 6 or 5.9.
Yeah.
1700 Oregon, Washington, California, 8.7 and 9.2. That's the original Cascadia earthquake.
Yeah.
And then the Aleutians 9.2
And we
in
have
1585.
records of earthquakes on the east coast of the U.S. going back to right after the Pilgrims arrived, which goes back to like 1638. So we do have records on the east coast, not so much on the west coast until people got out there, which was basically late.
And so everybody's clear. The last of the new Madrid earthquakes was December 16, 1811, which is between a 7.5 and an 8, right? California's quakes were on December 8th and December 12th. Both of these 6.9 to 7.5.
Yeah. So within a year, that same year, it came across.
Mm-hmm.
Yeah. End of 1811 into 1812.
Right.
And so all I'm trying to do is see what else it was doing on this east to west line coming across all the way from Crete. Now, I could have gone farther than that because India had a big quake back then in like 1810 and all that. It's on the same east-west line. But for now, I'm only going from Crete coming across to California. And I'm going to show like how it's done this before many times that we're just learning about now once you start putting all this information together.
Right. Now it's very hard unless you get to the Indian records or the native records, which I don't believe there's such a thing called natives, but hey, that's me. There's not many records for the west coast of North America. Just isn't.
Well, yeah, it's all based upon studies that they've done now, whether it's turbidite, tsunami deposits, tree rings, all sorts of stuff, fault and trench studies. There's multiple ways that they're doing it now. Right. So they get a date, and whatever that date is, they have a range on it depending on what it is and what they're trying to do now, because everybody's doing it all over. They're doing it up in Vancouver now, all along there. There's new studies about all the tsunami deposits up there, and they're matching dates with the ones done in Washington, Oregon, California, to see if the dates match. Are they close? Is there a range? And then they keep adding more stuff, and they're doing all these things I mentioned before, and they're trying to put them all together to see what the actual date was that the thing happened. The big quake, basically. And I'm going to show like how they're doing that now. And like a lot of this stuff is really new since like 2018 or 2020. And I'm going to show like how they're updating it and how they're going different places and trying to find when these exact things happened based upon what we've done with all our new methods and dating and everything else, trying to figure out all this crazy stuff. So what I'm going to do is only go back 1,000 years to show you how it works. Like they have stuff going back 10,000 years, but we don't need to go that far.
All right, let's get into it. So I think they've got kind of the idea. What we're doing is we're showing through the historical record that we can look up. You can research this yourself. Look up certain dates and to see what's going on. Not as, most of us who live in the world today, we live on a microwave oven kind of a mentality. Means almost instant. Oh, okay, boom, instant, right? Now, when it works with geology, there is a time frame that is much greater than what we look at. Yeah. We personally, Canuck and myself, we look at a year before, year after, only because we're trying to see the gist of things. If we went further out, we would see a whole lot more, and it would add more data, make it a little more confusing, because it isn't one big event, another big event, another big event. What happens is there's an event, couple other things that lead up, bang, couple things that lead up, bang, couple things that lead up, bang. And sometimes it's bang and bang, and there's things in the middle.
Yeah. So the big quake just doesn't come out of nowhere. There's a lead up to it. Correct. If you're paying attention, you can figure out what it's doing. And then you can go back and through all the sources of data you have, you can figure out what it's actually doing.
And no, we're not forecasting.
No, it's not forecasting, but you can see like how the pattern is over say a 2-year period, how all this stuff is all setting up. And like, we're not even approaching like the space weather angle and all that stuff right now. Like, you could, because you could find information in the 1800s and then add that all in if you want.
Right.
But right now, I'm trying to make it as
Right. Make
simple
it
and
simple as
straightforward
hell. Because it's never been presented the way we're trying to present it to you today. It's never been presented this way. Because earthquakes are, like they happen out of the blue. We don't know why. Science is changing a bit, and they're becoming a little more open to the ideas that what we're doing. And I don't think we're much of an influence, but maybe somebody out there sees it and goes, oh, yeah, let me try to do that.
We'll see. It's all information. So it's whatever everybody.
And I think the AI has been doing this already. And that's how come USGS is changing their ideas on a lot of different things, especially electromagnetic energy. But hey, okay, so we're in the Vesuvius thing here.
So the next one we're going to talk about is Campi Flegrei, because everybody's
Flegrei. Why is that so important? Because Campi Flegrei is happening today, everybody.
Yeah.
So
I'm not going to go into super detail about this, but I'm just going to give some points from this big long article.
Well, let's explain what Campi Flegrei is first.
Oh, it's a super volcano under Naples that's basically right next to Vesuvius.
Yeah, it's Vesuvius. Vesuvius is an offshoot of this super volcano.
Yeah, to simplify.
Yeah.
So anyway, this article that's here is updating. It's from last year, from 2024, but this guy writing it is given in the history of the ground shaking in Campi Flegrei going back to like 1500.
Yeah.
When it was really
1470, 1472, I'm seeing, yeah. A swarm.
Yeah. So he's talking about all these different things, and he said it was really busy from like in the 1400s and up to 1538.
So and then he said, let me read this article here. This paragraph. The most recent eruption at Campi Flegrei started offshore before migrating to land. It produced a nice new mount on the coast. Did a lot of damage in nearby area, wiped off the old harbor, and caused half the population of Naples to flee, which is happening today, everybody. Toward it to have a good look while it was still erupting. This all happened in 1538.
Yeah, so it was inflating back then too.
And as it described in a recent post, this was the first eruption, as far as we know, in 3,000 years. Was relatively small and was preceded by months or years or even decades of earthquake swarms. There has been plenty of warning. The first recorded earthquakes was in 1470 and 72. After that, there was inflation, just a few meters at first, but eventually reaching 14 meters. There were a few more earthquakes and swarms, but they accelerated about 18 months before the eruption and became damaging in the months before the eruption. After 1538, very little happened. There were major earthquake swarms of 1582, 1594, but that it did not lead to eruptions. Nothing significant happened then. Yeah. Now, do you want to read the next ones?
Yeah. Of course, I'll just read the other one here. Of course, there were other problems. The area suffers from uplift and deflation, Brady-Sizeism, of up to 12 meters. The old Roman town is now that far below sea level. One of the Roman towns in the area was at Pozzuoli, in the heart of Campi Flegrei. The unstable leveling was possibly one reason why it didn't age well. A new city was built farther down the coast, away from the unstable ground. That was called the new city of Neapolis, which that's what they called it then, which is now known as Naples. So Interesting stuff.
Meaning new city. Naples means new city.
Yeah. So it was quiet again for a while, and then the instability came back to Pozzuoli in 1950 after centuries of rest, where there was 70 centimeters of uplift over 2 years.
That's a
And
lot.
in 1969, locals again began to notice uplift on the shoreline. So it's been uplifting now for a while. Measurements confirmed that between 1968 and 70, there had been almost a meter of uplift. There were minor earthquake swarms in 70 and 71, which is interesting because 71 is the Silmar quake.
Silmar quake, yeah.
Small felt all the way across on the same east-west line. Things quickly calmed down again. There was a suggestion that some of the earthquakes that were decided or detected later in the 1970s were from fishing with explosives. Yeah.
Hey, we got some fish. Boom.
Yeah. But in 1982, uplift resumed, and in May 1963, earthquake activity
83.
in Erdis. 83 started with the magnitude 3.4 event. Well, 83 was the same as the years the Coalinga quake. Over the next 2 years, there were multiple swarms and events reaching magnitude 4. So kind of like what we've been having now. Uplift over this period reached 3 meters. People were evacuated. But again, things calmed down, and by 1990, measurements showed some deflation, so it was actually going down a bit. Obviously, there was no problem. Never mind that this was the first time since the 1538 eruption that there had been such uplift and earthquake swarms. Naples deals with the present, not the past, and whatever happened a decade before cannot be important.
We brought this up several times where the people in Naples, because of the beauty of the area, they're not moving. And the 4.0 uplift period of reached over 3 meters. People were evacuated, but again, things calmed down. By 1990, measurements showed some deflation. Obviously, there's no problem. Never mind. This was the first time since 1538 eruption that there has been such an uplift. Naples deals with the present, not with the past. Blah, 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 right? Yeah. Well, guess what happened on the 13th of this month? A 4.4. And inflation is happening now. We'll see.
Yeah.
We'll see.
So it keeps going down, and he gives all this detailed information on it, when it was uplifting and everything. He's given charts, and he goes through and he shows all this stuff, and then he's right.
Here's Vesuvius.
All the recent stuff.
Here's Campi Flegrei. Here's Vesuvius. Campi Flegrei begins out here and ends up on shore. That's what's happening now. Begins out here and ends up on there. Now, there are evacuations happening right now. I think mostly voluntarily, but, you know. Hey, Lake Girl, how are you, my sister? Love you. So
just to summarize all this.
Here's Pozzuoli on the coast.
Yeah. Campi Flegrei wasn't acting up in 1809 to 1812, but Vesuvius right beside it was going batshit crazy.
Yeah, it's going nuts. Right there.
So there you go.
I mean, it's related to the whole supervolcano, which this is the caldera.
Because really, Vesuvius is just on the edge of it. Right?
Correct. And we've seen volcanoes come out of other volcanoes all the time. And Vesuvius is just an outcropping of this. As the plates move, you know, a hot spot somewhere. Hey.
To summarize, if you're looking at this area, Naples, you have to look at both Campi Flegrei and Vesuvius. Because it's very rare that they actually go together. It's usually one or the other, but it's still the same area. They're right next to each other. So when you look all this stuff up, you can go back through time and see what else it's going off at the same time, either one or the other. So that's my rant on the volcanoes at Naples. And what this guy is saying, that it's done the inflation thing before and not erupted. So that's what he's basically saying. Well, it may erupt, but it may be not too bad like it was in 1538. So
All right.
So anyway, so that's the aside on that. So we're going to move on to the next
Moving
one.
Moving on.
Yeah. So we're going to go to the big article on the New Madrid. And I'm just going to read the title of it. This one is from 2019. And the title of it is 4 Major Holocene Earthquakes on the Real Foot Fault Recorded by Secungan, or I don't know how to even say it, Secungan, in the New Madrid seismic zone.
Secungan.
Yeah, Secungan or whatever.
Okay. All right.
Now, they've done this with multiple things, but I use this one because they're like very specific on the actual dates.
All right.
So they're using different. Yeah, they're using different. I'm going to explain how they do it first. They use different methods to figure out when the previous quakes happened on New Madrid. So they use the thing where they do a trench and cut into the fault. Then they do this stuff with the Secungan stuff or as well, because it has to do with them taking out the less and all that stuff and figuring out how old it is and when it moved and all that type of stuff.
Okay.
And another thing they're doing now, they're taking the sand blows and taking the stuff out of the sand blows and figuring out when that moved. And they're using all of these to coordinate the dates to find out when New Madrid has gone off the other times.
Previously, yeah. See, the New Madrid, or New Madrid, however you want to say it, sequence of events happened from Arkansas all the way into Missouri, and 2 separate faults, main faults, I believe, and it wasn't a one-off. No. It repeats, and because it figured out,
the last 3 times it went off, and that's what we're going to focus on for everything else that we're doing. So, of course, 1811, 1812, which you already talked about. Well, it also went off in 1450
and 900.
And 900.
Why do we say interesting events? We know what happened in 900.
Yeah.
And also in the 450 elsewhere. So he's laying a foundation. He's going to talk a little bit about this.
And like it goes into detail on this one. It shows which actual faults it was on.
Yeah.
And it gives diagrams and goes right crazy showing it all. And basically,
go ahead, read your
well, I don't want to go into it because we'd be here for hours just on this, but to simplify it, it made a triangle there.
Yeah. There's your triangle right there. 2 faults, 1 north to south, 1 northeast to southwest. All right.
So that's what it talks about. And like if you read down through this, it says they think it basically does the same thing every 500 years.
Right.
So you get at least 1 7 or maybe 3 7s. So I thought that was interesting. Because it seems like the faults are just one to the other.
Let me read the abstract and then you can pontificate there. 3 sequences well documented major M7 earthquakes 1811, 1812, 1450, and 900 CE. The New Madrid seismic zone, USA, contribute significantly to seismic hazard in the region. However, it is unknown whether this 550 year or less or greater reoccurrence interval has been constant throughout the Holocene, given a limited geomorphic evidence of prior earthquakes. We extend the record of paleo earthquakes along the Reelfoot Fault via investigation of ridge top gravitational failure features, interpreted as Secogen. The Secogen occurs in bluffs along the eastern margin of the Mississippi River floodplain and are concentrated near greater than 15 kilometers, or less than 15 kilometers, sorry, to the southwest dipping Reelfoot Reverse Fault. A paleoseismic trench excavated across the Secogen at the Pawpaw site exposed 4 packages of colluvial sediment that post-date 30 to 11,000 years, Peoria Lawless. We interpret the colluvial package to have been deposited following episodic failure of the Secogen as a result of strong ground motions from the following sequence of earthquakes. Event 4, 1640 to 1730. Event 3, 270 to 670. Event 2, 1430 to 380. And Event 1, 1810, plus or minus 50. Event timing corresponds to previously documented earthquakes and represent the longest archive of paleo earthquakes on the Reelfoot Fault. If the trenched Secogen record all major Reelfoot Fault earthquakes, or the observation in combination with prior investigations indicate a period of quiescence from at least 11 to 4.4 thousand years, followed by 4 major seismic events culminating in 1811 and 1812 sequence. This cluster earthquakes recurrence pattern helps place bounds on seismic hazard and geodynamic models in the New Madrid seismic zone. See, they're looking for issues of reoccurrence. That's what we're looking at. They're using it for a whole different view. We're just trying to understand how the system works. And earthquakes are part of a system, a greater system. So,
so anyway, they give the exact faults it was on.
Right.
And it's funny.
Here's the Reelfoot Fault. Here's the axial fault. Here's the Booth liniment right up through here.
Yeah, right? Boot Heel liniment and New Madrid liniment. So what I find funny, in these newer studies, they're called liniments again. So it isn't just faults now; they got liniments in there. And
liniments involved.
Where they happen. Yeah. So
now,
both
how they define a liniment might be a little different than how Canuck defines it, but
but they're using the same terms.
Right.
So 2 of those quakes were on the Boot Hill, New Madrid liniment, the first 2, and then the Reelfoot Fault was the last big one in February 1812, and it goes the opposite way. So one is northeast to southwest, where the first 2 quakes were on in, and then the one that's going northwest to southeast was the third quake, but it makes a cool triangle. I don't know. I just find that funny when I started looking it up and where the quakes actually were. I said, "Oh yeah, triangles. Gotta love it." Here we go again. But that's a whole other episode, the triangle thing. So anyway, what I want to focus on for this one is it happened in 1450. So they figure the recurrence rate on New Madrid is about 500 years. But you may get smaller ones in between, too, as well.
Right.
Smaller size quakes, which is basically what happened in 1699, right before Cascadia, 1700. Because there was a quake near Memphis, December 25th, 1699, which was 1 month before Cascadia. That was enough to knock missionary and I think it was French explorers and missionaries that were going through there in 1699, if I remember right. So they actually felt a quake and it knocked them off their feet when they were going through there to go to visit the native peoples. So it's pretty interesting stuff. So that was the first quake that Europeans actually recorded by feeling it in Tennessee on December 25th, 1699, 1 month before Cascadia, 1700.
Yes, Lake Girl, there was.
Yeah.
Yeah, 1700, yeah. All right, so in summaries, we completed that these 3 faults happened, or 3 earthquakes happened amongst 3 different faults. One is on the Boot Hill Liniment, one is on the Reelfoot Fault, and the interrelationship, we're not going to go really too far into, just that Missouri, Arkansas, and Tennessee are, all part of this. Memphis being in the south, this is north of Memphis. And it just so happens that I think Tornado Island or Tornado Alley goes above Memphis, a little bit.
And another thing that's interesting about this same time period, the Lewis and Clark expedition was up in the Cascade region, and I think it was like 1809, 1810, they were in like the Great Falls, Montana area, and they felt quakes when they were there, but they don't know if it was coming from the coast or if it was like somewhere inland. So Lewis and Clark were around up in the Pacific Northwest at that time, but there was hardly anybody there other than native people. So we don't have like any record if there was big quakes happening like off the coast up there between Alaska and Pacific Northwest. So we have like about 100 years gap in quakes up there that we're missing. So it wasn't really till later, mid 1800s, that you had more people up there that were able to be around and feel quakes and report it. Because Seattle just became a town in 1872 when the North Cascades quake happened. They just had elected a mayor that same year, so Seattle wasn't even a very big place. It was mainly lumber and fishing at that time. So it was a small place. So there's people up there then, so they could report when quakes happen because they felt them. So it's pretty interesting when you look into all the history of everything, figure out how it works. So anyway,
the Boot Hill Liniment is comes out of Arkansas, goes west of New Madrid. Most of the earthquakes, and I got an image to share with you, so let me just kind of pop in over here so that people excuse me. I'm sorry. Let me go like this. Go copy. Put this one in here. I'll get that one. All right. Go like that. Oh crap! Didn't like that. What did I do? There we go. I'm already sharing it, so you can see that. Cool. You can see marked tree, New Madrid, right? And you can see that most of the earthquakes are going this way, and then straight at almost a due south on this from Missouri into Tennessee. But the Arkansas one goes from Arkansas into that main line right there and then stops. We see the same kind of event happen on Ridgecrest and Garlock.
Yeah.
Ridgecrest and some of the other faults. What was it? A 6.3 and then the Ridgecrest 7.1 look just like this.
Yeah. So very similar.
And those things quaked for months and just kind of like the same. So I wanted to share that one because I went and I thought to myself, well, people don't know about the Boot Hill because it's not something we all know about. We all know about Madrid, but Boot Hill? And
so it's made up of more than one fault. It's just, well, that's because they call it the New Madrid seismic zone, right?
Mm-hmm.
Once you get down into it, you find out all the faults that are in there and see how one is relating to the other, right? So, but that's the same in any place you go to start studying this stuff. So, the next thing we're going to do is we're going to focus on 1450, which was the previous time New Madrid went big. And we're going to see what was happening back in 1450.
While the infamous, while the infamous 1700
pattern is the same, right?
Yeah,
that's what I'm trying to do.
While the infamous 1700 Cascadia earthquake is well documented, there's no definitive evidence of a major Cascadia earthquake at 1450. Some research suggests potential geological evidence, including sand sheets interbedded with peat and mud, which could be related to a quake around 1420 to 1450. However, these sand sheets are not definitively linked to a major earthquake. More research is needed to confirm the exact nature and impact of any earthquake that may or may not have occurred during 1450 in the Cascades. Now, I think that's pretty interesting.
The AI has read all the articles that I've read yet, because all the new stuff is saying pretty much it's 1450 for Cascadia.
Right. Yeah, Cascadia's eruptive is, I think, on a 300-year kind of cycle. And
no, actually, if you go to the 2025 data now, it's down.
Ding, 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 yeah.
243 years. That's the average between talking about age.
Right.
So that's the latest.
Talking about that.
Today, 2025, with the new stuff that Goldfinger and all the other people have added in since like the last year.
The Oregonian says 10,000 years of Cascade earthquakes. This is when happened, right?
Yeah.
Here's today, and they got all these name events.
Yeah.
So pretty interesting. Pretty darn interesting.
Now I'm going to focus on 1450 for now, but we're going to use that chart that I sent for the link too, because it's cool. You can click on it and it tells you all sorts of cool information. That's 10 years out of date, because that chart's from 2015. Right. I'm going to explain the difference between what it has on there now and what we have as of 2025. But to do
1468,
yeah. So I'm going to focus on 1450 now, and I'm going to start with crazy stuff in the Azores again happening.
All right. So the link you sent, let me see if I can see it. Is it this one?
Yeah, it's the one that says natural disasters in the Azores.
Okay, hold on. Da, 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 da. Natural disasters. Was it a Google search? No. ResearchGate? No.
No, it's a wiki.
Okay, I got it.
Yeah.
I jumped ahead. Sorry.
Yeah. So I wanted to see what information they had about what was going on around 1450 in the Azores, to see if this same line was going crazy back then. So the Azores was settled by the Portuguese early in the 1400s. So this list gives all the natural disasters that they had. So it talks about like famines, anything, eruptions, earthquake swarms, whatever. So I was just interested in 1450 for this one. So I looked, and then I saw, well, there's all this crazy stuff happening between 1439 and 1444. So that's pretty close to our age range.
Yep.
Yeah. So it's talking about it doing like the same stuff we talked about that it was doing in 1809 to 1812. It's talking about eruptions and all this stuff, and eastern part of the island changed, and all this crazy stuff happening. So it was acting up back then too. And they have a little information there to 1460. So it was basically acting up in the same age range that we're looking at for 1450.
Yeah, volcanic eruption in San Miguel and Ciudad's details. The eruption were not recorded, not even in the exact date of the event. Father Gaspar Futioso, who referenced the event in Saudis de Terra, noted that the inhabitants discovered that the topography of the eastern part of the island had changed radically and that tree trunks and pumice were found floating in the ocean. Colonists from settlements in now Povacao, the eastern half of the island, heard sounds of explosions and felt many earthquakes leading to the event. Living these discoveries in their straw huts, they heard in the space of a year such great grinding, rattling, and explosions of the earth, with great tremors preceding the subversion and fire of the peak. And in 1460, another volcanic eruption of Ciudades, San Miguel. No specific information was recorded at that time, though.
Yeah.
And that's what happens in this time period, right? 1460, right in that range. Volcanic eruptions happening in the Azores.
Yeah.
Now let's go.
Then I started looking up other stuff in 1450. And then the next thing I found was pretty interesting.
Mm-hmm.
And that's the next one about the big landslide that blocks the Columbia River in 1450. There's actually a Nick on the Rocks about that too.
Yeah, there is.
Yeah. So I'm just gonna read the article. It's from 2006, but it's pretty good.
Go ahead.
In about 1450, an immense landslide tumbles off Table Mountain in Skamania County. That's quite the name. And completely blocks the Columbia River, shoving it a mile off course. A lake forms behind the dam extending as far as 100 miles. The river will eventually breach the dam, causing a 100-foot deep flood downstream and creating the Cascades Rapids. This is the most recent of 4 documented slides in the 14 square mile Cascade landslide complex and will be called the Bonneville landslide. And then it explains like what it's made out of and all that. And like what it did at that time. So, and then it explains how they figured out this date, which is what I'm interested in. Radiocarbon dating of trees drowned by the lake placed the event between 1550 and 1750. So at first they thought this was related to 1700 Cascadia quake, that it made the landslide. But now we've got better at dating things. So
they're getting a lot better, yeah.
Yeah. So basically the newest stuff, like it goes down through and says this, but if you look at the stuff, especially that's happened like since 2015 onward, because this is just an article you're talking about from 2006, they're trying to figure it out. But now they've got better ways of dating the stuff that's in the landslide. So in all the new things, which is more than one study they've done, they basically said that it happened in 1450.
Well, what's interesting as well is the radiocarbon dating of the trees down in the lake place events happening between 1550 and 1750. Geologic record in 1869, the natives say these falls are not ancient and their fathers voyaged from the sea all the way to the dells. Now, the dolls or the dells, I call them the dells. That's significant, okay? And using share this tab, zooming out, going over here to Cascade, right? Here's the Astoria, the entrance to the Columbia. It comes all the way down through Vancouver, Washington. Here are the Dells, all the way in here. So they were able to navigate all the way on with their canoes. Pretty amazing.
Yeah. So they're assuming now that this gigantic landslide happened because of a big quake. So that's what they're assuming, and now they're trying to match up all these other things that they're doing to see if it matches with the 1450 quake date, which is, I thought it was interesting because it's the exact same time that New Madrid's going off. So see, we got that strange pattern again that Cascadia is acting up when New Madrid is acting up.
Again, what we're trying to show is that a pattern moves across the plate from one side to the other. Next one.
Yeah. Which is kind of talking about the same thing again.
Right. Well, the famous Cascadia earthquake 1700, there's also evidence of previous around 1450. Researchers have found coastal deposits, including sands in the sheets, sand sheets that suggest a large earthquake happened around 1450. That's what I read earlier because I was a little ahead.
And I've read the actual studies, so I'll just explain the Vancouver one. So where they did the tsunami deposit studies up there is right by Tofino, because we've talked about Tofino before many times.
Yes.
So that's where they did it, and they found out based upon, and this is like fairly new, like since 2020, they've gone up there and done it all over again, and they basically figured out that it was 1450 when there was a Cascadia quake that deposited there. But now they're debating on if it was a minor rip of the top. So not a 9. They think it was an 8. Because it shows up in stuff that comes down to the Columbia River, but it's not showing up below that.
Uh-oh.
So from this thing, this is all new just in the last couple of years. So they're wondering if it had like an 8 that didn't come all the full way down. So that's what they're debating right now and trying to figure out what it was. But it was still big enough to cause the landslide on the Columbia River to block it temporarily.
I think we lost Canuck. No? Did we lock up? Oh, why did he? I think he muted himself.
I don't know.
Maybe it's me.
I don't think it muted. If everybody,
sorry, it's me. All right, I found it. I don't know how it jumped. All right. Yeah, I guess no, it's still there. I don't know how that happened.
I don't know. Didn't like us talking about that, I guess.
No, it didn't. Somebody didn't like that.
Yeah.
Well, I'm back. It was me, not you, that was gone. But I lost you too.
Yeah.
All right. So on this map here, we're talking a landslide that blocked the 1450. That's one event that anecdotal evidence, you got to kind of read into it. So it's still not ironclad. What else?
But it's getting better with the new stuff.
Sure.
So the next thing we're going to go to is the actual fancy chart with all the 10,000 years of Cascadia quakes on it.
Right here. All right. There you go.
Yeah.
Here's the 1468 AD.
Yeah, and on this, so this chart here is from 2015, but I like it because you can click on each one and find out information about it. So if you look at the ones that are on it, you'll see, well, it has 1700. And then it actually has 2 8s close together in the mid 1400s.
Yeah, that's what I was looking at.
So that's pretty interesting. So that's data as of 10 years ago. So they from the stuff they were looking at in 2015. So it has all the turbidite things, but they've added more turbidite ones since 2015.
There's 1152 AD, which I think it's a significant range.
Yeah.
873 AD. Remember, there's plus or minus on these.
Yeah.
Right? That could be 900.
Yeah.
There's a 707 AD. There's a 521 AD, 396 AD, a 130 AD, 86 BC. So the latest.
Now, I was just interested in mid 1400s and
1400, yeah.
And around 900, because I'm only going back 1,000 years to find information to see how all this stuff connects. So, but anyway, on this, I have to explain this chart. So this chart is from the turbidite data that Goldfinger did up until 2015. So there's basically 40 Cascadia quakes above 8 on this going back 10,000 years. But since this happened, because this chart's from 2015, they found out was another one. So there's 41 now. So once you add in the other ones that they found since then from doing turbidites all over inland and in lakes and stuff, they're finding more. And now they're finding all the inland quakes, which could be 7s. So eventually, whenever they update this thing, I don't know how. There's 41 for sure now that were 8s that they know as of 2025. So when you add more in that are 8s, it's reducing your frequency of it going off, right? So that's why they had it 500 years before when they first started doing this stuff between big quakes. Now it's actually down to 243 because they're adding in all the other big ones that were like 7s as well now, which I'm going to show you after this is a new study from 2024 that they're adding all these new ones in that were like 7s, either just off the coast or farther inland, because they're doing the turbidites, taking the core samples in all these lakes.
And using turbidites to date things. Okay, let's give a summary here. You just did that. So let's get into the details, I guess.
Yeah. So the next one is one of Goldfinger's newest studies that just came out. That's the one we're going to look at.
All right. So what does that say? Which one is that? This one here. Goldfinger. Okay. November 22, 2,700-year record of Cascadia mega thrust. Is that the one you want?
All right. Yeah. So where this one is, I have to explain where he's doing it. So this is like down in southern Oregon, like 100 miles from the coast. So pretty close to the California border. And it's in a lake that's called Acorn Woman Lakes, Oregon. So this is what he's in, getting turbidites out of, and then dating the stuff that's in here. So
I'm going to read the abstract then, okay?
Yeah.
Okay, we infer a 2,700-year history of cascade megathrust and other earthquakes from 2 small mountain lakes located 100 kilometers inland of the coast near the California-Oregon border. We use characteristics of disturbance deposits in the historical portion of the sediment cores attributing to the 1700 CE Cascadia earthquake to identify cascade earthquakes deposits down core. The deposit shows evidence of small bypass turbidite followed by a deposit composed of light-colored silt, indicating it is enriched in calcium-rich Slickier Creek watershed source sediment without visible mica or mica grains, which would indicate a lake bedrock source, organic grading and deposit tail, and basal contact with evidence of rapid loading or the influence of sediment water interaction during a seismic shaking. 7 deposits down core have the characteristics of this deposit. An age depth model suggests that 6 of these temporal correlatives to the largest margin wide marine turbidite event deposits from the Goldfinger 212 events T1 and T6 or through T6, whereas the 2 deposits with some of the characteristics of our potential correlative of smaller turbidites T5A and T5B. Other thinner deposits are temporal correlatives T2A and T3A, and other smaller deposits of uncertain origin. Lake core physical property data can be correlated to those of the offshore cores containing seismogenic turbidites attributed to the Cascadia earthquakes. These results suggest that the small Cascadia landsides dammed lakes with sufficient sedimentation rates of 1.2 centimeters per decade. The mixed clastic and organic content may be good recorders of subduction earthquakes, which can be differentiated from other types of deposits. So basically, they're using assumptions by dating certain things, and they can see larger earthquakes from smaller earthquakes and how the lakes respond based on sediments coming down into the lake and building silted layers. Yeah. And it's dating those silted layers is how they place it on a list, and then they try to correspond it with other events from other locations so they can see a regional wide
so see if the samples
event.
match up with their other spots that they're doing.
Yeah. And once
And
they
of
start
course,
to date
for this one, I'm primarily interested in the most recent ones.
Mhm.
So I'm going to summarize like what he found from this one. Well, in this lake, they found the 1700 one. That was pretty obvious. Well, they also found out the most recent one wasn't 1700. It was actually 1873.
Wow.
Which was the big quake that happened off of Southern Oregon, Northern California in 1873, which was, I've talked about it before. It's the one that happened the year after 1872, where you had Owens Valley and
Correct.
you had North Cascades, and then you had in the middle offshore Oregon.
Okay, what was happening in 1870s during, I think it was Charlotte was happening, but other earthquakes across North America? Anything else that was happening?
I'm not going to worry about that right now. I just want to talk about that California to
Go ahead.
Cascadia. So now he says in this, he said based upon like the turbidite that was there that identified 1873, he said they've said that quake in 1873 was too low. He says it should be at least 7.
Mm-hmm.
Yeah. In order for it to be able to make a turbidite that they could identify. And I think that's like 100 miles from the coast, the southern coast of Oregon, where that lake is. So, and like when it did the 1872 and 1873 thing, it made a big triangle again. So here we go with the crazy triangles. So it's like 3/7.
Okay.
So we have the crazy triangle pattern again, 1872, 73. So I thought it was interesting that he added that one in here. And there's like a bunch of other ones. He has a chart down here where he shows like all the turbidites, and he's showing all the ones that it showed in that lake compared to the ones that he had offshore Southern Oregon from the earlier ones he did back in the early 2010s. And so he was finding that there was other ones showing up there that he assumes are sevens that have not been recorded, that were like probably offshore or inland, that caused turbidites to form in the core samples he was taking. So it gets right crazy because he compares like he shows like, once you get into the charts thing, this is not showing up in this one. It's not loaded, but he compares them.
Here comes the 4 point that just came in. Yeah, the 4 point something. 4.0 Terrapocket Chili. That's what's ringing through.
But in this one that was in Southern Oregon, he didn't have the 1450 in there, but there's ones in the 1300s. So I thought that was interesting. So this mystery 1450 quake that shows up in Vancouver and Washington and up Columbia River wasn't showing up in his ones that he was doing in Southern Oregon. So that's the debate that they're having now. So there was like an 8+ up there at the top, but it didn't come all the way down to the bottom because there's no turbidite of it inland. So I thought that was pretty interesting. So it's opening up that the top of Cascadia can go 8+ without it going all the way through. Because previous to this, they thought that it has a whole bunch down at the bottom, which it probably still does, but like
it does.
7,
it goes more often in the bottom.
Yeah.
The Dalles. There's a question as what are the Dalles? The Dalles Oregon was founded in 1857. Was a large original site to Fort Dalles, the U.S. Army outpost built to protect settlers from Indian attack. The Dalles formed the last stop in the Oregon Trail before pioneers floated down the Columbia to their final destination. Today, the Dalles retain the charm of Oregon community with roots in Native American and pioneer history. So it's just a place where there was a fort. Okay. I hope that answers that question for you.
Yeah.
So anyway, the place where a dam is.
One they updated again in 2024. They did this one originally 2022, but they just updated it with new stuff and put it out again at the end of 2024. It came out like December. There's a bunch of people been all talking about it like since this year started, January 2025, debating all this stuff. And they're using like different ones from all over. So I use this just as an example because it's one of the newest ones. But they've been doing other lakes all over. And Goldfinger's been doing stuff in Southern California too to figure out the 10,000-year record of Southern San Andreas quakes. Because he already did Northern San Andreas ones. And what he found from that is basically that when Cascadia goes off with an 8, the Northern San Andreas usually responds to it.
Or the Cascadias are a response to what's happening in the south. One or the other.
Well, they think it was weird that 1906 went big in San Fran without Cascadia going first. But maybe it did if it had a 7 in 1873 at the bottom. See? Yeah. So like if you look up the 1873 offshore Oregon quake, they seem to be, they say it's like a 5 or a 6. But Goldfinger is arguing that it was probably at least a 7 in order to make the turbidite that he found in that lake. So he's disagreeing with what the other people say.
Yeah, everybody has an idea, right?
Yeah, so it's pretty interesting. Now I haven't been able to find any of the new stuff that he's doing in California. I know he was off the coast, off Long Beach,
right,
all that, a year or two ago, and he was doing stuff with John Dolan.
Yeah, Sometimes
And
it
all,
takes a few years to get that research published, and
yeah, because I guess
it's
the
got to get
first
through. It's
thing,
got to get through peer review at all as well.
yeah, that when his first turbidite thing came out in 2012, 2013, it took him 13 years
Right.
of stuff before he got it.
Well, mind you,
And
he was still doing other stuff,
yeah,
but he's
oh,
got a
they're
lot.
always doing other stuff, but
Right, he's got a lot of stuff in the can, but still.
yeah.
So we've been waiting for Goldfinger's latest because he's one of the more well known. All right, so let's move on from the Cascade. Let's go to the next.
Yeah, so the next one we're going to do is a new study from very recent on Garlock.
2018.
Yeah.
All right.
And you'll see who the main author of this one is.
Alex Hedman Dolan, James Dolan.
Yeah, James Dolan.
Right.
So he's like one of the main guys that's studying all the faults in
Right.
Southern California. He
Right.
actually started out doing faults in Turkey.
Now, what's interesting that he's talking about here is this Dolan guy. They developed a model to show the kind of quakes and in their sequences through Southern California. There's three main kinds of quakes in where the Garlock is involved, and I think it's kind of interesting, and it's kind of a progression of things. So I'm going to read the abstract, and we'll look at the map. Yeah. We develop a model for evolution of activity along the Garlock Fault that combines elements of three previously proposed mechanisms. 1, a conjugate slip of the San Andreas Fault. 2, an extension on the basin range. And 3, bending from oblique shear in the Eastern California shear zone. Conjugate slip is the greatest in the west and decreases eastward. Conversely, extension-induced slip increases westward from the eastern termination of the fault. Oroclinal bending provides only a small contribution to the Garlock slip that increases eastward from the east central segment. These spatio-temporally complex loading patterns may explain alternating periods of fault activity along the Garlock and neighboring faults. Moreover, these complex kinematic relationships demonstrate that the Garlock Fault acts as an efficient mechanical bridge linking slip on the northern Eastern California shear zone and the San Andreas Fault that may have delayed or even obviated the long hypothesized development of the new Pacific North American plate boundary along the California shear zone, i.e. Walker Lane. Interesting. This is a real interesting article. I'm going to show you the map here. I already have it on there. Let's see if everybody can see it. Yeah, you all can see it. And what about Canuck? Canuck can see it too. Good.
Yep.
So.
Well, I'm looking at it on my.
Right.
Thing.
Yeah. I just wanted to make sure you were able to see it.
Yeah. So this study is from 2018, but now I'm going to explain what they've been doing since then.
Okay. These three lines at the top, so people can kind of get the gist of what's being said here. And you close some of these pages. These three lines right here, that fault is the 1872 quake. You know, the great Pine Valley fault. That one moves up through Pine Valley. The second one is the Panamint, and the third one is the Death Valley. So 3 main faults, they go to the north. And in the southern part, I don't know what these faults are, but you'll see. You'll see down here. I want to say they're the ones that go behind from through Bishop and through behind the.
Yeah, that's what I'm going to explain next.
Okay, cool.
Because I want to tell you what they're doing since this study.
All right,
so
good,
Alex
good, good.
Hatem, that was his graduate student back in 2018. Well, he has a new one now. So if you look up the newest stuff, it's Fougere is this graduate student.
Yeah, now he's got another student working now.
Yeah, so all their new stuff that James Dolan's name will be on it, but he'll have his graduate students too. So I watch like where he sends his graduate students to do stuff. So anyway, since 2018, what they've done, they've still been working on the Garlock. They've broken it down into 3 sections: western segment, central segment, and
hold on. Yeah, it'll knock you out. Just all right. I don't know why it's showing it. Oh, it was an update. That's all that was. Sorry if you're hearing the bells. Those are particular earthquakes that are happening right now. All right. So continue, Canuck.
So they divided it into 3 segments so they can do trenching on it and figure out when it's gone off before. So all the new studies that come out since like 2022 are basically on the western segment where it meets the San Andreas, and the central segment, which is close to Ridgecrest. So that's what they've been most interested in because of the stuff that's happened like since 2019.
All right.
So what they found so far is both if you look up both the western segment and the central segment, they say it was super active in those 2 segments between, well, they go back 2,000 years, between like 2,000 years ago and 500 years ago. But when they've done the actual trenching, what they agree on now, that the last time the Garlock went off with a really big one, I think 7.5 was in the year 1450.
All right, I don't have a listing for that link.
No, I don't have all those because there's like, I'd have to put like 4 of them in here.
Well, the one you're referring to, if just because you're looking,
I'd have to find the 2024 one again.
All right, cool. Because that one's really the critical one we're looking for.
2024.
Sorry about that, everybody. We're always having trying to keep things in order. We'll get it. We'll get it. Garlock acts 3 different ways. So, and there's some slowness to the southern portion of it and more speed in the upper. So, I'm still thinking what the heck valley that was. I just probably have to look it up.
Yeah, this same one that I'm trying to find also says now the Owens Valley fault and
that's
the
what I was
airport
looking at.
Fault are all the same fault.
The airport?
Yeah, the one that Ridgecrest 7.1 was on.
Yeah.
It was all the same.
Yeah, so what stopped it was the break.
Seen that little study that they're all, they consider them all one fault line now.
Yeah. Coso Junction is a welding point where magma came up and welded together. So the reason I think the Ridgecrest quake got stopped was due to the welded tuff that's at Little Lake all the way to Coso Junction, and it didn't go all the way up. I think at Olancha is where it stopped actually. It didn't go all the way up,
which is just below
the valley.
Owens Valley Fault ends.
Yeah, the Owens Valley broke in I think 1872, or real close to that, and it ripped at somewhere in the range of 8. So some arguments of saying it's stronger than the Great San Francisco earthquake, or it's not as strong because they've been downgrading the San Francisco 8 all the way down to 6.7 or even a 7 now. It's like, I don't know what the hell it is. 7.6 maybe. Depending on which article you read or which scientist is talking about it. But in looking at this, here's Lone Pine, here's Olancha, here's Ridgecrest. This whole valley right here, all the way up to June Lake, that's the Owens Valley. The next one over is Panamint. It too can do an 8. And Death Valley, which is even further inland, it can do up in that same region. So looking at the schematic, we're seeing a 3 at the top and then 2 at the bottom. One is the Fort Irwin, and that's probably this one. And the other one is what goes through Barstow, and that would be all the way down here, and that would be probably Landers, and this one would be quite possibly that other quake, that 7.1 that happened out here. Landers was 7.3. This one was a 7.1. Hector Mine. So, and then both of how they line up. So Landers is related to the Ridgecrest, 7.3 here and a 7.1 up here, and then Garlock it splits them in between, and what it does is it tells these ones to move at different speeds. That's kind of what the supposition was back in, I don't know what year was this, 2018, but Canuck is looking up right now the most modern one and waiting for him to post that.
Yeah, I'm trying to get one here that has the
Indonesia,
like
Sumbawa.
Yeah, the whole friggin' thing in it with everything.
Mm-hmm.
No, that doesn't have it all.
So the idea is that Garlock is what controls the top 3 main faults and the speed with which they break. One being a base hit and range, which is the number 2, remember, and the other being the first one is conjugate slip of the San Andreas. The base hit and range is number 2. 3 is the bending from oblique shear of the Eastern California shear zone, and that's what the Hector Mine is about. So
can't put it in there now.
Kind of down those going.
From the seismic site.
All right. Refined Holocene slip rate of the western central segments of the Garlock Fault, recording alternating millennial scale periods of fast and slow fault slip. We use LiDAR and field-based mapping coupled with single grain infrared simulated luminescence dating to constrain 3 new slip rate estimates from the western and central segments of the Garlock Fault in Southern Cal, revealing a more complete picture of incremental slip rate in time and space for this major plate boundary fault. Plate boundary, you hear the key word, plate boundary? These new rates reinforce and refine previous evidence showing that Garlock Fault experiences significant temporal variations in slip rates and that span multiple earthquake cycles with multiple millennial periods of very fast or 13 to 14 millimeters a year, early and late Holocene slips separated by mid Holocene period of slow 3 millimeters slip rate a year, similar to 8,000 year slip rates for the central Garlock fault of 8.8 to 1.0 millimeters, and an 8.2 to plus or minus 1 or 0.8 millimeters a year for the western Garlock fault, demonstrated that the fault has slipped at faster long-term average rates than suggested previous studies. These fast rates are consistent with kinematic models in which western and central Garlock fault segments are driven primarily by lateral extrusion associated with the north-south contractional shortenings, with additional slip driven by west-northwest, east-northeast, base interrange extension north of the fault, and minor rotation of the Garlock with the north-south zone of the dextral Eastern California shear zone. So, non-technical summary: advanced geomorphic mapping and dating methods allow us to study the Garlock fault in Southern California. Past research shows that some of the major faults show that irregular behavior over thousands of years in time scale. Specifically, our findings show that during the same period, some periods, the Garlock fault has been slipping faster than its long-term average rate. I mean, we've covered this like, oh my gosh, late last year we covered this. And other times, this fault has been slipping slower than its long-term average rates. These new insights build onto existing data and allow scientists to better understand and the complex behaviors seen in the fault network, ultimately better informing seismic hazard assessments. That's what they always put it as, that better informing seismic hazard assessments.
Yeah, because that's what they're focusing on. Because
Right.
they're trying to get the recurrence.
They got to make money. Yeah, they got to make money. So,
so
go ahead.
The recurrence rate that they think for Garlock is 1,000 years. Every 1,000 years, and the last time they think it went off was 1450. So our same time period that we're talking about. So New Madrid off 1450.
So the Garlock fault is a major left lateral strike slip fault that extends eastward from the intersection of San Andreas Fault for 250 kilometers southern Death Valley. It forms a prominent physiographic boundary between east-west extension of the basin range to the north and extending Mojave Block to the south. Culminating displacement along the Garlock fault is recorded as 48 to 64 kilometers since fault initiation, which occurred between 17 and 10 million years ago, and likely 11 million years ago. The Garlock fault has been divided into 3 segments defined by changes in strike and structural complexities. Specifically, a 2 to 3 kilometer wide step over at Cone Lake between the western and central segments coincides with 10-degree change in strike and 15-degree change in strike near the Quail Mountains between central and eastern segments. The east-west Garlock fault is embedded perpendicular to the Pacific North American plate boundary motion within a zone north to northwest trending dextral shear known as the Eastern California Shear Zone. The central and eastern segments of the Garlock fault lie within that zone, but the western fault segment lies to the west of this zone of the dextral shear. Then they go on to explain all the different studies. New slip data from the central western Garlock. I think that's what we've covered that already too in some of our other studies. Offset measurements, we talked a little bit about them as well. Age constraints, Dolan 2016 roads. All right, so that's already been talked about.
Yeah, it's the 2016 one that they give the dates.
And here's the refined. All right, main text, introduction. All right, previous studies. I don't know if that's the same one, but talk about the slip rate.
Yeah, Dolan's name is on the one from 2016 where he says 1450, and they think also between 675 and 900.
Right.
So there's our other range date that we haven't done 900 yet.
Right. which will probably add to the. We're already about, we're 2 hours in.
In the other one from 2016, he talks about how it connects to the San Andreas as well.
Right. I think this is a good place to stop where we're at, because I like to really dive into these 3 articles on the next rabbit hole, because I think this is the crux of what you're saying regarding the Garlock and how it functions. And if there are dates that correspond with some of these other dates we're talking about, 900 and 1450, and then probably somewhere around 1,000 or something in there as well. And then we go all the way to 1700. And then if we go up into another 1800, 1810 or 1812, that's establishing the movement across the plate and what's happening, and how this little area down here, the Basin and Range, and whether it's the movement of the North American plate smashing up against the Pacific plate, grinding it away and shoving everything from the south to the north, and how it's being buzzed off. North America is being buzzed off by the movement of a much faster plate, which is the Great Pacific Plate. But North American plate's no dope either. Plenty of dopes on it, but needless to say, I think this is a good place to kind of stop right there, because we've established what's happening from Etna. We talked about Crete prior. The week before, we talked about Crete, and we kind of updated you on that. And then we talked a little bit what's happening in New Madrid. And now we talk a little bit about Pacific Northwest, and now we're in the Pacific Southwest. And I think when you get there and you start to dive into some of these articles and you get into the depth, I really think you see that the pressure being pushed from the Garlock is really, really related to the Cascadia Range. And the data, the anecdotal data that's happening, we're going to see the correlation of numbers start to solidify as we look on the West Coast. And then we can see the progression from the middle part of the United States and Canada and Mexico all the way to the Atlantic boundary, and how it moves out from there. And that's kind of what we're after. What we're after is to show you a progression across the North America American plate, and it is seen in these radical movements. Now, you can also see it in small quakes, like what's been happening over the last week or 2 weeks. We're seeing, not weak earthquakes, but significant quakes, 3s, propagating across North America in kind of a pattern. And I think we can talk a little bit about that on Wednesday. We're on Saturday now.
Yeah.
It's been a long week with my boy, but Luke Klemmer, and he's Well, he's probably somewhere in Nebraska now. So let's pray for his safe journey home. And I appreciate Canuck where we're at. We've already gone 2 hours. I don't want to, you know, get too tired. Overdo it. Is right. But I think these 3 articles, the Dolan and Goldfinger and what's the other guys? Hayden. I think these 3 articles.
Yeah, whatever it is. And then Fougere is the newest guy.
Yeah, the Fougere, yeah. So we're going to dive into these articles specifically in the next rabbit hole on Wednesday. So it won't be so complex. We won't throw so much at you, but we're going to digest these 3 articles and try to give you an understanding what's happening in the Pacific Southwest, because it's
and I'm going to show that New Madrid and Garlock area and Cascadia all went off in 900 as well as
right, and they're all related. Yeah. That's the key. Everybody hears about Cascadia, right? And that's where all the studies going on, because it's so interesting, because there are volcanoes up there.
So we're going to be in big trouble long before Cascadia goes.
Yes, again. Right. And and probably those in the middle of the United States, sorry, it's going to get you guys first.
And it's going to go east to west, and it's going to be trouble.
And there's a progression. And
I'm not worried about the volcanoes. I'm more concerned about the earthquakes.
Yeah. Well, the earthquakes are going to set off a volcano here in the west.
Take out our major cities.
I'm not so much worried about Yellowstone. Yellowstone has to burn itself through the continental plate of North America. It's no longer burning through the accreted terrains where it would blow up more often. It now has to burn through the continental plate, which is a lot thicker. And so that magma spreads out a lot more underneath the plate. And, I just, the thickening of the North American plate, which has already happened, there's no, tried and true, what's going on in the Yellowstone. There's a lot of people. Oh, it's going to blow. It's going to blow. Blah, 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 blah. Why? What do you know that none of us else know? It's your opinion. I got it. There you go.
Yeah. Well, the Cascadia volcanoes are only going to take out what's right next to it, but the Cascadia quake is going to take out Portland, Seattle, and Vancouver.
Yeah.
And not to mention all the other smaller places along the coast. Right?
And in addition to that, there's let's say a young man in 1937 had a dream. And he dreamed this whole thing and how the whole world was going to respond. And it's very interesting how certain events are happening and what we're discovering that, hey, maybe his dream was true. So, and I don't remember the kid's name. Do you?
I can't remember now. Yeah. But in 1450 and 900, there's just
Joe Brandt's dream of California.
Indigenous peoples there for all these big quakes in their teepees. So they didn't have all this other big stuff that can all be destroyed in a quake. So who was actually smarter, them or us? At that point in time. So it's pretty interesting when you start trying to figure all this stuff out. So a big quake back then wouldn't be as big a deal is what it would be if the same thing happened now, just because all the stuff we have built up there to get wrecked. So.
Yeah. I appreciate you there, Canuck. Is you want to close out with anything, bud?
No, that's it.
All
So
right.
that's the tease.
So please come back, everybody. And if you're over there on Rumble, if you're on there on YouTube, just remember we're going to talk a lot about the functionality of how Garlock is and how it works and how it's related to both New Madrid and Cascadia, and how the greater function of the North American plate, how it moves. Right, everybody. Thanks a lot. And I appreciate you. Remember, don't get none on you. I love you. You can see me over here on twitch.tv/JoeSlick Live, Monday through Friday, 7 to 9 o'clock, somewhere in there, usually about 8 o'clock, Arizona time. If you can't figure that out, I don't know what to help. I don't know how to help you. With me here in Arizona, Canuck out there in New Brunswick, we appreciate you. Appreciate you listening. We appreciate your tips and your subscriptions. Help build this channel. Share these videos, and make sure you like and follow and talk about it. Hey, add questions in chat, man. That's all you got to do. You want to engage us? You can engage us Monday through Friday over here on twitch.tv/JoeSlick Live, and for the morning show, morning report, and then Wednesdays and Saturdays, the Rabbit Hole. Thanks, everybody.